Okay, now we will have 5.3. So what we have here in 5.3 is statistical analysis for two population mean. Means that you will have mu1 and mu2. This one is for the independent cases where the samples are drawn independently. So what is independent sample? Independent samples are measurements made on two different sets of items which the samples are taken independently. For example, you have sample A and sample B. For example, I want to estimate the difference between two sections, the difference of marks, statistic management, two sections. So I have marks for section 1, I have marks for section 2. So this sample and this sample is independent. So we call it as independent sample. Okay, how to estimate the difference between these two independent samples? We will use a confidence interval. So let's look at the formula. Okay, first you need to consider, is there any population variance there? If there is population variance, you have to use the first formula, Z test. Next, if population variance is unknown, you have to look at the population variance. There will be an information from the question. Assuming that both population variance is unequal, look at the sample size. If sample size equals or greater than 30, use the second formula, Z test. If both sample size is less than 30, use the third formula, T test. T test here, if you notice there's a nu. Nu is this formula, and you have to run down the value of nu. Next, if in the question they said that both population variance is similar, look at the sample size. If sample size greater than or equals to 30, use the fourth formula, Z test. And if the sample size less than 30, use the fifth formula, T test. For the both population variance is equal, you will notice you have SP here. So the formula for SP is this one. So don't worry, you don't have to remember all this formula. All these formula are given in your statistical table page 5. Okay, this one. Alright, so let's look at how to solve example 5.2a. How to solve example 5.2a. Suppose the random sample of 100 waiting times observed under the current system give a mean 8.79 and another random sample 100 waiting time observed gives a mean 5.14. So from the first sentence, there are informations there. There are two samples, okay, which is sample 1, the sample size is 100 and the sample mean is 8.79. For sample 2, the n is also 100 and the mean is 5.14. Assuming both population variance is known, means that sigma 1 and sigma 2 is known and equal to 4.7 and 1.9. So you have sigma square here, 4.7 for sample 1 and 1.9 for sample 2. Construct a 95% confidence interval. So confidence level is 95% for the difference of population mean. So mu1 minus mu2, different. Okay, how to solve this exercise, this example? Alright, first, which formula that you want to use? Okay, look at the formula. they said that sigma 1 square and sigma 2 square is known. So, known, use the first formula. Okay, the formula is x bar 1 minus x bar 2 plus minus z alpha over 2 square root sigma 1 square over 1 plus sigma 2 square over n2. So now we have to substitute all the values. We have sigma, we have n, we have x bar. We have to find what is z alpha over 2. So from the confidence level, alpha is 0.05. So alpha over 2 is 0.025. Z 0.025 is equals to 1.9600. Okay, substitute all the information into the formula. So confidence interval x bar 1 is 8.79 minus x bar 2 5.14 plus minus z alpha over 2 1.96 square root sigma 1 square is 4.7 over 100 plus 1.9 over 100. So you have to put into your calculator and the answer will be 3.15, your lower boundary, and 4.15, your upper boundary. And then don't forget to interpret. We are 95% confident that, so you can copy from here the difference of population mean of waiting time between two random samples, that the difference of population mean of waiting time between the two samples lies between the lower boundary and the upper boundary, 3.15 and 4.15. That's it. Exercise 5.4a. Universities Placement Centres collected data comparing the starting salaries of graduating students with surnames beginning with the letters A through M, if those begin with N through Z. So there are two samples here. First sample, surname A through M, and the second sample, surname N through Z. For a sample of 31 students, so that one is the sample size in the A to M category. So sample size for A to M is 31. The average starting salaries, average is X bar, is 3,700 with a standard deviation is 300. For N through Z, the sample size is 36, the average is 3,300 and the standard deviation is 250. Assuming normal distributions with unequal population variance, construct a 97% confidence interval for the difference between two population mean. So mu1 minus mu2 of the starting salary based on their surname. Then give a comment. So from the question, we extract information, sample size, X bar, and the S. And also we have 97% confidence interval. So confidence level 97%. Right. So which formula that we want to use? We know that this one is for mu1 minus mu2. So let's look at the formula for mu1 minus mu2. So there are 1, 2, 3, 4, 5 formulas. So which formula you want to use? Okay. Is there any sigma given from the equation? No, there is no sigma given, so you cannot use formula number 1. Okay, to use formula number 2, 3, 4, 5, we have to look at here. Sigma 1 not equals to sigma 2. Sigma 1 not equal to sigma 2. Sigma 1 equals to sigma 2. Sigma 1 equals to sigma 2. So which line that give you this information? So look at back the equation. So this line, unequal population variance, means that sigma 1 square not equals to sigma 2 square. And here your sample size is more than 30. So which formula? Here. Sigma 1 square not equals to sigma 2 square, and the sample size more than 30. So we should use this formula. Okay, then the formula for confidence interval is x bar 1 minus x bar 2 plus minus z alpha over 2 square root s1 square over n1 plus s2 square over n2. Alright, so let's check. Do we have all the informations? Do we have the x bar 1? Yes. X bar 2? Yes. S1? Yes. N1? Yes. S2? Yes. N2? Yes. So we don't have this one. Z alpha over 2. Where can we find it? From this confidence level. So confidence level 97%. Your alpha is 0.03. So alpha over 2 is 0.015. Z 0.015. Look at your stat table. You will have 2.1701. Okay, now you have all the values. Substitute back into the formula. X bar 1, 3700 minus x bar 2, 3300 plus minus z alpha over 2, 2.1701 square root s1, 300 square over 31 plus s2, 250 square over 36. And then press your calculator. You will get the lower boundary is RM 252.19 and the upper boundary is RM 547.81. Because we talk about the salaries, we have the unit RM. So this is your confidence interval. The difference of population mean between these two is between these two confidence interval, and you need to give comment. So how did you give comment? We start with we are 97% confident that, okay, you can copy from here. The difference between two population means starting salaries. The difference between two population mean of starting salaries lies between RM 252.19 and RM 547.81. That's it. That's for exercise 5.4.